Finally, a picture of the Milky Way's supermassive black hole. Shh. Listen to it carefully. Is there anything that exists in the black hole? What will be inside it? Are there only wind blowing or some powerful cyclones also there? Or can a black hole be the gateway to any other universe? There are lots of mysteries that come into everyone's head after hearing the name black hole. What comes to your mind when you hear this term? Tell me in the comment section. After seeing this video, you'll be like, the mystery of the black hole at the heart of the Milky Way has been resolved. Let's dive into the video. So, the Event Horizon Telescope, or EHT, astronomers discovered that the first impression of Sagittarius A, the supermassive black hole at the center of the Milky Way, on May the 12th at a simultaneous press conference around the world. It's not the first time this collaboration has given us a picture of a black hole, the iconic image of M87, which they disclosed on April 10th, 2019. But it's the one they really wanted. The image is a long-awaited look at the massive object at the heart of our galaxy. Previously, scientists observed stars orbiting around something invisible, compact and humongous at the center of the Milky Way. This strongly suggested that Sagittarius A is a black hole. Our own private supermassive black hole, Sagittarius A, is still the location around which our galaxy revolves. Scientists have long believed that a supermassive black hole embedded deep in our galaxy's chaotic central region was the only possible explanation for the strange things that occur there, such as ginormous stars slingshotting around an undetectable something in space at a significant fraction of the speed of light. However, they have been hesitant to say so outright. When astronomers Reinhard Genzel and Andrea Ghez shared a portion of the 2020 Nobel Prize in Physics for their work on Sagittarius A, their citation stated that they were awarded for the discovery of a supermassive, compact object at the center of our galaxy, rather than the discovery of a black hole. That level of caution is no longer appropriate. Because black holes absorb everything that falls into them, including light, they are effectively invisible. However, they warp the space-time around them so severely that they cast a shadow when exposed to light by glowing streams of infalling matter shredded in their gravitational grip. The shadow is roughly 2.5 times larger than the event horizon of a black hole. Its boundary and defining feature, the line in space-time through which nothing that passes can ever return. The EHT captures images of this shadow using a technique known as Very Long Baseline Interferometry, or VLBI, which combines radio observatories from multiple continents to form a virtual Earth-sized telescope, the highest resolution instrument in all of astronomy. The EHT collaboration spent several nights in April 2017 pointing the virtual instrument at Sagittarius A and other supermassive black holes. The first finished product from that effort has already been seen, M87. During the same campaign, the team collected raw data for the Sagittarius A image, but converting those observations into an actual image took much longer. That's because Sagittarius A is ever-changing. M87, the black hole at the center of the galaxy Messier 87, or M87, is so massive that it takes many hours for matter swirling around it to complete a full orbit. In practice, this means you can stare at it for a long time and it will hardly change. Because Sagittarius A is 1,000 times less massive, it changes 1,000 times faster as matter moves in tighter, faster orbits around the black hole. According to Kate Booman, a computer scientist and astronomer at the California Institute of Technology, who co-leads the EHT's imaging working group, matter orbits Sagittarius A so quickly that it changes minute by minute. It's difficult to take a time-lapse photograph of a speeding bullet. As a result, deriving a clear image of Sagittarius A from the information recorded during the 2017 observing run has taken several years. Have you seen Christopher Nolan's amazing masterpiece Interstellar? There is a reference to a black hole in that movie. I personally love that movie. How about you? Tell me in the comments. The mercurial nature of Sagittarius A makes it difficult to see, but it also makes it an exciting laboratory for future research of black holes and Einstein's general theory of relativity, his hallowed theory on gravity. Astronomers already knew Sagittarius A basics measurements, mass, diameter, and distance from Earth with great accuracy after decades of study with various telescopes. They can now, at long last, watch it evolve in real time as it feeds on flaring, flashing streams of matter. In the early 1960s, not long after the exploration of active galactic nuclei, extremely vibrant regions at the cores of some galaxies illuminated by avidly feeding supermassive black holes, scientists began to suspect that a black hole lurked in the heart of the Milky Way. Active galactic nuclei are a thing of the past from our perspective on Earth. We only see them in the distant universe. What happened to them all? Donald Lyndon Bell, an English astrophysicist, claimed in 1969 that they didn't go anywhere. Instead, he claimed they simply went to sleep after their heavy meals. He predicted that dormant supermassive black holes are slumbering all around us in the centers of spiral galaxies, including our own. In 1974, American astronomers Bruce Bialik and Robert Brown pointed radio telescopes in Green Bank, West Virginia at the Milky Way Center and discovered a dim speck they suspected was our galaxy's central black hole. They discovered the speck in the constellation Sagittarius A. The news source's radiation was lighting up, or exciting, the neighboring clouds of hydrogen. Brown named the newfound speck Sagittarius A*, after the atom's physics nomenclature, in which excited atoms are denoted by an asterisk. Radio astronomers gradually improved their view of Sagittarius A*, after the next 2 decades, but they were hindered by a lack of suitable telescopes, relatively primitive advanced technologies, think reel-to-reel magnetic tape, and the intrinsic difficulty of looking into the galactic center. A multi-layered veil conceals Sagittarius A*. The galactic plane, 26,000 light-years of gas and dust that hinders visible light, is the first layer. The scattering screen, a turbulent patch of space where density variations in the interstellar medium knock radio waves slightly off course, obscures radio waves as they travel through the galactic plane. The completely destroyed matter surrounding the black hole itself is the final layer concealing Sagittarius A*. Peering through that barrier is similar to peeling the skin off an onion, because the outer layers emit longer wavelength light, making VLBI work with shorter wavelength light would allow for close-up views of the event horizon. That, however, poses a significant technological challenge. Meanwhile, radio astronomer situation has improved. In the late 1990s and early 2000s, a new generation of high-frequency radio telescopes became available, capable of participating in VLBI observations at microwave frequencies thought to shine from the edge of Sagittarius A shadow, is outfitted with specialized equipment. Simultaneously, the computing revolution that resulted in solid-state hard drives and smartphones in everyone's pockets significantly increased the amount of data that each observatory in a network of radio telescopes could record and process. Scientists have known for a long time that a black hole should cast visible shadows under certain conditions. Physicist James Bardeen predicted in 1973 that a black hole in front of a bright background would show its silhouette, but he concluded that there appears to be no hope of observing this effect. In addition, astrophysicists Heino Falke, Fulvio Malia, and Eric Agol demonstrated in 2000 that a microwave gathering, Earth-sized radio telescope should be able to see Sagittarius A*'s shadow against the glow of its surrounding ring of shattered matter. But one more question must be there in all of your minds. Can a black hole harm us? So, the multiverse is a magnanimous place, writes Elizabeth Landau of NASA. In particular, in companion to the size of a galaxy, the size of a region where a specific black hole has substantial gravitational influence is quite limited. This holds true even for supermassive black holes, like the one discovered in the center of the Milky Way. This black hole has most likely already eaten most or all of the nearby stars, and stars further out are mostly safe from being drawn in. Because this black hole already weighs a few million times the mass of the Sun, swallowing a few more Sun-like stars will only result in minor mass increases. There is no danger of the Earth being drawn in because it is 26,000 light years away from the Milky Way's black hole. Future galaxy collisions will cause black holes to grow in size, for example, by the merging of two black holes, she continues. However, collisions will not continue indefinitely because the universe is large and expanding, making any sort of black hole runaway effect extremely unlikely. And that's all for this video. If you have any queries or suggestions in your mind, feel free to put them in the comment box. Also tell us, what do you think this telescope is doing? Will it achieve the ultimate goal? Will we be able to know exactly about the past? Or do you think these efforts are futile? Whatever you have in your mind, do not forget to let us know in the comment box. And if you like the video, please like, share, and subscribe. And thanks for watching!